Can't fucking see it because his microphone's in the way. Sorry about that, everybody. Apparently I wasn't streaming. Fun times. Fun times indeed. So it is a little bit after 11 a.m. because I'm a couple minutes of not streaming. Happy Thanksgiving, everybody. It is 11 a.m. We're doing JavaScript interview questions, or at least I hope we are. Are we live? I can't tell because I only have one monitor today. I'm supposed to have more than one monitor, but somebody didn't order the part when they were supposed to. So I don't have another. Hold on. Let me just get to it. Let me see if I can get to the right one. Okay, I think we're live. Now I've actually looked and verified, and we seem to have a screen this time. All right, let's start over. Fun times indeed. Okay, so yeah. Hello world and happy hacking. Welcome to webdevcourses.tv. My name is Mark, and I will be your instructor. We are doing JavaScript interview questions. And let's see, for the job. Okay, so you have to be careful about where you get your information on the internet. It's one of the reasons why I do what I do. There's so much bad information out there. There's so many YouTubers that don't know what they're talking about that are giving you advice. There's so many websites out there that just have completely wrong information. You have to be able to understand. It's hard, right? Because you don't know a lot about JavaScript. But I'm going to show you an example of bad JavaScript questions, and I'm going to show you an example of good JavaScript questions, and then we're going to go through some of the good JavaScript questions. Also, if you go to a JavaScript job and you get questions like this, either they don't know what they're doing, or the person that is hiring for the position has no idea about programming or JavaScript. That's what this article reads like. So, like, the first question, number one, is what is JavaScript? No, not that important. And if it is, this is not the answer you'd give. You wouldn't say it's different than the Java language, blah, 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 blah. You'd say it's the language of the web. It's what's in every browser. List and features of JavaScript. Lightweight. These people have never written JavaScript. Interpreted programming language. This part's correct. Good for the applications which are network-centric. Who wrote this? This is not English. Complementary to Java? No. Complementary to HTML? Yes. Open source? Sort of. Yes, sort of. Who developed it? It doesn't matter. Brendan Eich doesn't care if you know that he baited. He doesn't care. It shouldn't matter. It's Brendan Eich, but like, who cares? It just has no impact on your ability to get a job or to do a job. List some advantages of JavaScript. Server interaction is less. These people have clearly never used JavaScript. That's not true. There's far more server interaction with a asynchronous JavaScript application that's sending requests to servers all the time. Feedback to users is immediate. Depends on how you write it. Interactivity is high. Interfaces are richer. I mean, maybe. Depends on how you write it. Disadvantage, no support for multi-threading. Sure. Most languages don't have it. Any dynamic language I know of doesn't have them. Multiprocessing, it's basically the same thing, right? You do it either through multiple process or you do it through multiple threading. Go does this, Rust does this sort of thing. Reading and writing files is not allowed. Whoever wrote this, clearly not a JavaScript programmer. You can read and write temporary files in client-side JavaScript all day long. You have a local storage, you have a local database, you could write files to those things all day long. You can't write to files on the client system, sure, but JavaScript also runs on the server. You can certainly read and write files. So this is just junk. This is garbage. Also, I got down to define a closure. This is not a closure. That is a side effect. It's not the same thing. To be a closure, this would have to be inside of the function. and then it would return the value. It's closed over the value. So anyway, garbage. Java T-point, you get a failing grade. You clearly might know your Java. You don't have any idea what you're talking about with JavaScript. Goodbye. Okay. Let's go on to somebody that gets it right. Sood, Hair, Jay, whoever you are. I'm just going to give you a star because, yeah, this one is much better. I haven't looked at the answers. I've only looked at the questions. But the questions, not only is there a lot, and the questions, they are good. Okay. JavaScript, people say it's an object-oriented programming language. It's not. But because of that, I love that they start off with objects. I start off with functions because I'm a functional programmer. They're starting off with objects because people think it's an object-oriented programming language. My guess is by the end of these questions, you'll definitely question if JavaScript is a functional programming language, a prototype programming language, a class-based language. Like you'll know pretty quick. By the way, classes and objects aren't the same thing. Classes come from something else. Objects were from Smalltalk, and objects are supposed to mean a specific thing, and they really don't anymore. All right. What are the possible ways to create objects? So you can use a literal, const obj lit. Here's my object. I have a name. I can't do that because I'll get threatened with doxing by YouTube. I've got a house. That house has a color. That color is blue. We've now got one value, which is the string. What else does it have? Stories. 2. So this is an object. You get back an object that has a key with a house. It has a value, which is an object. It's another literal. And it has 2 keys. One is a value, a string. One's a value of an integer. Both of them are integer or value values. They're not references, but because they're inside of a reference, there's not much difference. Okay, so you can also do an object that is like a object. And for this one, you just do new object. But I don't really see a lot of point in doing this. You can do it, but it's the same thing. You could probably have something like an array, and then you want to do a reduce, and you want to have that number. So you have your accumulator, and you have the n, and you just want to do the accumulator is returned as a new thing. We destructure it, and we're going to add the n onto it. This, oh wait, no, that wouldn't be an object. We're going to do something like ACC equals new object. And then we'll say dot, 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 ACC. Actually, we don't even have to, we could just do a parens after this to force it to be an object. We could say we want to take the n value, make that a string is one way of doing it. Because we want to have like a string value sort of thing. So if you took that and you put it inside of square brackets, it becomes a variable essentially for the key. And then you could just give it an n. That would also be an object. There's a lot of different ways to create objects. Honestly, the literal is the only thing that I've found to be a whole lot of use. You can also create an object with assign and with bind, and I mean, technically you're not really creating an object, you're moving an object or copying an object. Get rid of that last one, because the last one is convoluted. It's something that I would know because I've been doing this forever, not necessarily everybody else. Right, so you can do this. Yeah, you could call create. I don't really write object-oriented code, but yeah, object literal. You can apply an object in a function constructor. Yeah, but it's still, oh yeah, I don't write this kind of code. This is the kind of code that'll get you in a lot of trouble. This is very, very, what's the word I'm looking for? This is imperative code. When people say imperative, what they're talking about is this. This code example right here with the this keyword is not any fun. Depending on the rules of the game, depending on what kind of lexical context you're in, depending on what kind of function it is, depending on what kind of variable type you're using, like this changes all over the place. So my advice is the same advice of Douglas Crockford, who ran the Yahoo JavaScript Foundation forever. This is just an icky thing to use. If you can get away without using this keyword, you'll be happy. Okay. Oh, shit, I didn't mean to close that whole thing. I wanted to go back to the questions. Close tabs. Very thorough research on the part of this person. All right, so next question. Prototype chain. What is the prototype chain? Let's take that out. Let's create a new file. Call that one.js. Rename this one 2.js. All right. I don't need my outline. What is a prototype chain? Might as well just copy that, put it in the code. What is a prototype chain? So we finally are immediately driven straight into like what JavaScript actually is. It's not an object-oriented programming language. It's a prototypical programming language. And what that means is you can have something like the array prototype. And you can access it by its prototype. It's like a secret function. It's not really supposed to exist. Whoops. I don't want them. It's not really supposed to be something that you mess with unless you're messing with the prototype chain. This is inheritance. I always prefer composition over inheritance. So one of the reasons why I don't do this often, like I won't do array dot new function equals, and then I give it some new function. I don't do this sort of stuff. The reason why is it's called monkey patching. We don't own this object. This is the prototype that's owned by JavaScript. It's not ours to modify. So this is one way that you could do it. If you wanted to make your own, you could do something like, okay, so I've got this car. I'd use a person, but YouTube's crazy with their banning and censoring and shadow banning. So const car is a new object, right? Or we could just do an object literal. And actually, we probably need a real object. Honestly, I think I would return it with a function. I would say that car is a new function. What does this do? And we could use an arrow function too if you guys want. This is essentially your constructor. When you call a car with a capital C, you're going to pass some optional arguments. Let's say that we do it a color. And if you don't pass anything, it's blue. We would return a new object literal, and that would have the color of the car. It could have other stuff. It might have like a function called check oil, which should just do, true. It's going to do something. We haven't written any code for that yet. So you could just take this, put this down into that object that's returned, and you now have a blue car if you want. If you so choose, you can have a new blue car. So how do we know that this works? How do we know that we're not writing code and the interview is going to be like, yeah, and well, we could run it. So new car is not a constructor. Whoops. What did I return that as? Oh yeah, I turned it into a function call because I don't like the new keyword. I just don't like it. I think the new keyword, this keyword, they're not necessary. They're necessary in like these little tiny circumstances, but you don't build your entire knowledge of a code base based on edge cases and corner cases. You build your code base based on the golden path, the best path, the positive path. It'll make you write a lot less code if you do it this way. We're not actually printing this off, so we don't see it. So let's just log it out. We got a blue car. Sure enough, we got a blue car, and we got this function that can check the oil. So how would you call that? Well, we'd just say blue car dot check oil. It's going to return our a true or false, depending on if we have oil or not, right? It's a true. Okay, so we have a car that has like essentially a constructor, and then we can attach stuff to it. What if we wanted to attach this to the prototype chain? What if we wanted to say something like, okay, well, I have a function called check oil, and right now it can just return true. And I need to get this onto the car. This car is just an object when it gets returned. So I could say, I could access the prototype. I can access the prototype by like actually accessing the prototype, but I don't need to. I can just say that this thing has a check oil function, and that check oil function is this check oil function. Or if I really want, I could just do a function expression, and this will actually have the lexical context of getting access to this stuff. So let's say that we add oil level, and if it's below a 3, then we are low on oil. So rather than check oil, which is an imperative thing, I want to return that into a functional thing, which is just like, check oil is like, what does it return? We don't know. Check oil could return full, half, empty. It could return a decimal. It could return a fraction, which is a rational number. Like, it could just return lots of different stuff. Low on oil is true or false. So how will we check the oil level? So if it's less than 3, let's say that it's low on oil. So if I was to call blue car dot low on oil, low on oil is not a function. Probably because I'm returning an object literal. Let's see. Car dot low on oil is a new function that returns a value, but this is here. That's what's in here. We're returning this object literal here. What if we switch that to a new object? There's a lot of different ways we could do it. I think the way that most people would do it if they're writing this is they would go to this keyword and they would just say the oil level is maybe the oil level. Let's pass that into. Say that it's a 2. So if you don't give it an oil level, actually, how about this? If you don't give it an oil level, it's a 0. So I think this is how most people would write it. And the reason why is because you can see that when you have like an object inside of a function, you're returning the object literal. Like this keyword is not going to automatically bind up, especially if we use an arrow function. This is why I don't write this kind of code. It becomes complicated. You have to know all kinds of inner details about JavaScript that you shouldn't really have to know. I know them and I just don't want to use them because it's complicated, and trying to teach people that new thing is not fun. Okay, so now you could do this. This is not needed. It does this anyway, but again, I like declarative code. I don't want to get to the bottom of this and go, what does this return? I want to know what it returns. It returns this. Still oil, no, it's not a function. What the hell is going on? J. Okay, so I set a brand new car function that returns a thing. Let's just make this an actual thing. Get rid of the arrow function because that changes lexical binding. We've got const car, blue car. We have oil level color, so that just return us a blue car with an oil level of 0. We should get back that new blue car. This is putting it on the static level, on the class itself. Properties, set properties of undefined. Oh, because I got to do like what? The underscore on the end now. I don't hook into prototype this way very often. It's not very safe. Still no. Okay, fine. JS underscore underscore proto. Oh, that's right. That's the eigen class. That's the eigen class. What am I doing? I was writing Ruby yesterday. Don't write Ruby and then switch to JavaScript. Let's add the new function onto the prototype. Prototype. Not onto the eigen class. That would just be setting it back to the static. Like, makes no sense. Still not a function. What am I doing wrong here? Oh, well, I guess those should be keyword arguments if I'm going to give them default values. Oil, this, this, this. So before I call this, let's just look at what that car looks like. The easiest way I know of to do this sort of thing, JSON.stringify the thing, because you can just print it out simply. Are we on to? Yes, we're on to. Okay, good. I was wondering, maybe we weren't even in the right file. So blue car says it doesn't want the quarks. Why don't you want the quarks? What version of NVM am I on? Oh, I was on 18. I don't think that'll make a difference, but I was on 18. Reading color. But I put that in quarks. Oh, I'm not in Vim. What am I doing? I'm typing Vim keys. I'm not even in Vim. Let's take the keyword arguments off. Converting circular to JSON. Okay, fine. What about if we just check the color just for now, just to see if it's there? Color is there. We don't need to stringify it anymore because it's a value. Okay. And what's the oil level? Oil level is 0. So if this was a function, I'm going to get rid of like any of the lexical binding stuff with the arrow function. This is, people think that it doesn't matter. All this stuff matters. When people tell you that like the arrow function and the regular function are the same thing, it's not true. It's really not true. There's all kinds of rules. If you don't write a very specific type of JavaScript, which is the JavaScript that I write, which is based off of the JavaScript that I was taught to write by essentially guys like Doug Crockford, bad things happen. Things get very complicated very fast. Okay, no. Now I need my new car because I've switched it. It's no longer an object literal. Again, rules. You got to like know all of these things if you write this kind of JavaScript. Okay, so false. So clearly I've got a logic problem and I need to stop trying to do my Vim keys. This dot call level is less than 3 would be true. What did we get? We got false. Okay, so my guess is now that this is not bound anymore. So console.dir, this. Let's see what JavaScript has to say about it. What is it? Okay, it is the car instance. That's cool. So even without doing the arrow function, we get the value of this bound to our object, which is super cool. If you use ES6 classes, this doesn't happen. You have to use an arrow function in that case because ES6 classes aren't actually real. All right, so our oil level is 0. Our color is blue. That seems to be fine. You could say, you know, Mark, TypeScript would have found that, and I would have to say you're correct, but I also found it. Okay, so now we've got an object. We've modified the prototype. You can modify the prototype of the prototype to do inheritance. So like you can only have one other object in your prototype chain, but you can have more than one. That's how you get an inheritance in a prototype language. But you're cheating. You're using call or assign too early. Nobody knows. Yeah, but nobody knows what apply is yet. I guess you're not doing it linearly, and I'm trying to do it linearly. Oh, never mind. I was already on the next one. Oh, so all they show is prototype chaining is used to build new objects from the old objects. There's no code. There's no actual code example. Okay, I thought they were trying to show us that you could do it with apply and bind, and I'm like, wait a minute, that's completely cheating because we're not to apply and bind yet. Oh, I guess we are. Okay, so this is the gotcha. What does Derson call, apply, and bind? The correct answer is I only use bind because the other two invoke a function. They don't return a new function. I'm a functional programmer. I'd rather have the new function. I can invoke it whenever I want. So call and apply, they both invoke a function call that will return you a new object that essentially you can pass in some state, so to speak. You can modify the lexical binding. The difference between call and apply is that call does it with the arguments are sequential. So argument 1, argument 2, argument 3, argument 4. Like if you took an array and you put a spread operator on it. Apply gets the thing that you're changing, and it gives you an array of values to pass in to like basically decorate the new object. Prototypical inheritance, the way that it's done, is a type of decoration. It's actually from functional programming. Okay, so call and apply do the same thing. They work with a function invocation, but they just have different ways to pass in the arguments. Bind returns a new function that does the thing that you want it to do, plus it gives you the arguments in an array. All right, the difference between call, apply, and bind is explained with below examples. Call method invokes the function, right? It's an invocation. It invokes a function, which is given this value so that you can bind it. And arguments that are provided one by one. So it'll do this dot name, this dot last name, this dot first name, this dot last name, this dot first name, this dot last name. As you can see here, that's what it's doing. So they're binding the object to the new thing along with the arguments that you're going to send to the object. But you'll notice that they're sequential. So it's hello, comma, hello, how are you, blah, blah, blah. The next one is the same exact thing, except you get this array instead. It's the only difference between between call and apply. It's just one is sequential arguments and one is an array. Bind is the one I like. Bind allows you to take the thing and then bind something else to it. So we've got this invite object. It's a function that returns an object. Actually, it's just a function. It doesn't even return an object, but it has access to this lexical binding. So what we're doing is we're putting these values in. I guess it is not an array, but sequential. So you pass them in sequentially, but the binding happens here. So it's not like this is all like one line essentially. And this one I usually do bind, and then it's the employee. And then you do, dot, and then you can do the next part and pass and pass and pass. That's usually how I do it. Right. Call and apply are pretty much interchangeable. It just depends on like if you're trying to do the array or the index. And they both invoke immediately. That's the thing I don't necessarily like about it. I prefer bind creating a new function that'll have a new object is really what it's saying. That'll have this keyword bound. Okay. Big ass file. Okay. What is JSON and its common operation? So JSON is just JavaScript object notation. There's really nothing special about it. It's turn your JavaScript objects into something that can be serialized as an object that can be serialized as a string. So they have quotes around all the keys, whereas in JavaScript objects you don't. Common operations for JSON. Well, you would do stringify, you would do parse. There might be some like byte packing stuff that you do depending on what's inside of the JSON. But basically it's for transferring data over a network boundary. That's what JSON's for. Right? So you can parse and stringify. Doug Crockford. I'm sorry. I mean, you guys can call it hero worship. You can call it argument based on authority. You can call it all kinds of logical fallacies, but the simple fact is Brendan Eich wrote JavaScript and Douglas Crockford wrote the book on it. So between the two, if they're your heroes, you're going to write a very specific kind of JavaScript. And if they're not your heroes, you're going to write a bunch of garbage. What is the purpose of the array splice method? What is the purpose of the array slice method? What is the difference between slice and splice? This is really one question. My love, can I have a coffee, please? Can I have a coffee, please? All right. Like I said, it's really one question. It's easier to show you the code. What number is this? This is 567. All right, so we have an array. That array has 1, 2, 3, 4, 5, 6, 7, 8, 9. Slice and splice both do the same thing, that they're attempting to access this array at an index, from an index to an index, basically. The difference is that one will return you a new array with the stuff changed. So let's say that we wanted a new array that had all the values, but we didn't want 4, 5, or 5, 6, and 7. That's what we want. If we use slice, we get this. If we use splice, we get this. If we use slice, the original array is still that. If we use splice, our original array now looks like that. That's not good. That's a side effect. And I don't like side effects. So slice, splice, that's the difference. So the same thing, they do the same job, but one of them is functional. It doesn't do a side effect. It doesn't change stuff outside of itself. And splice is imperative, and it does all kinds of nasty shit if you're not paying attention. I guess I must just finish that into real code, otherwise it's not going to save correctly. So this would be array.slice, and we'd want to what? Get rid of the 4, 5, and 6. So 0, 1, 2, 3, 4. Slice. We want to slice out 4, 5, 6. We want to return the original array. If we do this, this is 5, 6, 7. We get 5, 6, 7, right? We sort of want the other thing. Like we want something that will give us back this with this gone. But using composition, like it's actually quite easy. You could write a function that would do it. Let's say that we were rewriting like shift, unshift, push, pop, those sort of things. So we're not working from the middle anymore. Let's say that we want to take that off, and we want to do it in a functional way, not an imperative way, because we could just call like, you know, pop and pull it off. Or we could like delete it at index. There's a whole bunch of imperative ways of doing it. And honestly, I think they're all kind of gross. How about we go from here to the array length -1. What does that give us? Okay, so that gives us what we expect. It knocks off the last one. What if you were to call it over and over? What would happen? Just call it a bunch of times and see. It's idempotent. It means that like you could run it over and over and over, and it's just going to do the job once. It's not going to like keep track of state and jiggle things around. Idempotent things are awesome. They're very easy to debug. Let's do the exact same thing. Let's switch it to splice. I still haven't figured out what the key is to do this. There it is. It's like a several combination on this one. Thank you, love. Okay, so what happens here? Let's run it again and find out. Whoa, what happened there? Right? So the reason is this doesn't return anything. It's imperative. It doesn't return anything. So let's do the same thing, but this time in fixing the fact that like this is not going to return you in a value. It's going to make a side effect, and then you have to check it again. Huh. That didn't work, right? Like it's just, it drives you mad. The differences between slice and splice will drive you crazy because this is imperative and this is functional. The functional one, I don't know, man. It just works the way I expect it to work. Let's hard code some stuff here. Let's say, okay, fine. We have this array. It's got a 9 in it. Why does it have a 9 in it? Because we did the splice operation and it's modifying the array. Okay, well, what if we flip it around? What if we say splice 1? What do we get? Okay, so we get the 1 value out. That's interesting. What if we did a 9? Interesting. So essentially, the interface is different, right? Now, I don't know about you, but I would expect the slice and the splice interface to be the same. It's really, to me, it violates the principle of least surprise, the fact that they're different. All right, so, and if you've done my React stuff, you'll know that I don't like this sort of behavior, and I always normalize it so like the interface is even straight across. All right, so what happens if we did, well, what if we did that over and over, right? What are we going to get back? It's getting smaller. It's getting smaller and smaller each time we call it, which means it's not idempotent, which means that it's imperative, which means that like debugging this is not going to be any fun at all. So there's the difference between slice and splice, and there's the difference between imperative and functional programming. And honestly, that tells a better story than I could imagine they're going to tell you. So let's see what they tell you in 3 questions. Let's see. Slice is return selected elements and a new object. Yeah. Give me from this one to this one, this one to this one. Give me all the ones up to this one. Or no, give me the one just at that place. And then we get the splice one, which is, it changes the interface. It still looks like the same interface, but it does not work the same. Slice doesn't modify. Original returns a new subset used to pick elements from array, blah, blah, blah. See, this is not really correct because you can use slice to do this too. And it returns the deleted elements as an array. So like you can see the interface is very different between the two. How many have we gotten through? I think I'm going to see if anybody has any in the chat. My window's up here. By the way, how are y'all doing out there in Twitch and YouTube world? All right, let's make this a little bigger because I can't freaking see it. All right. Okay, so what is currying? That's a good question, Josh. Currying is something you really won't have to work with in JavaScript very often, but you should know what it is. So if you've got a function, and that function takes an A and a B and a C and a D. The concept of currying is you should be able to have a function that just takes an A and a B. And then you say, Okay, well, what if we only took one? How would you get through all of these things if you could only call one of those values at a time? There's a lot of ways that you can do currying. There's some built-in mechanisms that were added recently, and then you can always do it the way that we've been doing it forever, which is JavaScript. The way that you would do this here is you would have to know what are the arguments of this function. We look at the arguments of the function. We'd have to go over each one of them. We would use, I'm not going to write the code here because it'd take a little while to write the code. We're going to essentially call each of these in chain, and we're going to compose them together. So what you end up with in the end, I'll just show you what like the call stack would look like. You end up, it'll stop doing this. You end up with something that looks I guess I'm going to have to use arrow functions, otherwise it's going to be all pissy about it not being an expression. All right, so that's going to be another call to another arrow function. I might as well just do arrow functions all the way down at this point. Okay, so you're going to have a function that calls A. It's going to also give you access to B, which is also going to give you access to C, which is also going to give you access to D, which probably doesn't need to be a function call. The thing about this right here is it's actually probably going to be backward because you're probably going to actually walk it this way. Just the nature of like the way that things are sort of reversed. Oh shit, I'm not showing this in my... What screen was I on? The chat screen? Okay. Thought I flipped over. All right, so currying, you've got a function that has, you know, like 4 values, right? You need each function to only take 1 value. I'm not going to write the code that does the thing. What I'm going to do is just show you this, like, looks like this. The function that you want to call, let's just say that it's fn. I don't care what it returns. Returns true. How about it returns n mod 2 equals 0. So it returns whether or not it's a an even or an odd. So that would be even. Let's say it is even. So you got this is even thing. Currying means that you're going to have something that's like, you got this thing, it's got you're going to be operating over something, but you're going to have a function that's something like this, and you can only have a function that's something like this. So what you end up with is you end up with something like this. It's not going to look pretty. I apologize ahead of time. Welcome to functional programming at its most extreme. I don't really deal too much with this stuff because it's, you can do it, it's esoteric most of the time, it's not needed most of the time. I guess that last one wouldn't be needed. Actually is even wouldn't work because it doesn't compose. But the concept is you end up with this chain of currying like this, where the previous function will call the next function, and then essentially you have access, right? So if we were looking at this like this, you would have access to A and B here. And you wouldn't have access to A and B otherwise. So you could do something like const p1 equals curry, and that's going to be, I'm going to pass it a 1. That's going to say const p2 equals p1, and I pass the b, which is like a 4, right? So now I can say console.dir p2. Get rid of the garbage code. This is called currying, so node currying, not return it. Then you get that. So if you look at the code, each of our functions only call one of the values, but in the end, you end up with both of them because of currying. This is also called partial application. JSON is like a shopping list with a standardized format. That's actually pretty spot on. Actually, yeah, totally. Yeah, you can see my beautiful face. I know. I have to give you something for Thanksgiving, you know. Yeah, it's a super edgy case, and most people can't answer the question or write code to do it. This is, if I had to have a go-to example of like why you would want currying, what partial application is, I would say this is it. And I would point out, like, you could go through the arguments. Every function has access to the arguments that were passed like with the arguments call. There's all kinds of ways you can do currying, but generally, other than partial application, which I do find very useful in JavaScript because of the concept of closures, I don't find currying much use except for partial application. Again, but you see me return functions with functions all the time if you've watched my stuff before. It's nothing new for me. What's up, Gervy J? I'll just call you J Grill, though. I think J Grill is still a better name. Thanks for joining us on Twitch. So, everybody on Twitch, my whole 2 people, happy Thanksgiving. Thank you for watching me on Twitch. Love you. All my friends over on YouTube as well. We are coming to the end of this session. Remember, this is an ongoing class. So tomorrow we're going to come back and we're going to do a whole bunch more of these. We're going to do a whole bunch more. I want to thank the channel producers. I was off a couple days because the SSD drive in my computer died, and so I couldn't stream. And it's very expensive to stream. Look, I gave up a very lucrative business to like do this every day with you guys. And so far things are looking good. I'm happy where things are. I'm happy where the projections look, but I do need your help to pay the rent, buy food. I have 2 teenage boys now. They eat everything in the house like locusts. Shoot that tip jar if you get a chance. If you find that the things that I teach are useful, if you find that you come back time and time to my videos, shoot that tip jar. Give me $1. Give me $2. Give me $20. Give me $100 if you can. It's pay as you can. Julie on here, Ryan on here, they pay me between $100 and $140 an hour depending on the work I'm doing, right? And Josh Vaughn has given tons of money to the channel in tips, and like, you know, some bucks here and some bucks there. Chris, the same thing. I know Chris doesn't make much money. I'm working on helping him get a job, and he's tipped the channel several times, so he definitely deserves to be on this list. We've got Thomas Lawrenson, who's at least given me 1 tip the last session that I did. I just want everybody to know that those go to that new hard drive that I had to buy, and then after that they go to paying for the power and the, you know, the air conditioner and stuff. And, you know, my wife gets her money and the boys get their money basically before I get my money. So if you want to support a small business, that's what this is. So again, I've been Mark. This has been WebDevCourses.tv. And this was JavaScript interview questions. We will be back tomorrow with more of that. And we're coming back in a little bit. I'm actually going to come back a little bit late. Let's say 12:15. If you get a little bit early, I'm sorry, but I have to take a potty break. So we're going to be back at 12:15 for designing UX using Tailwind CSS. And yeah, then we'll take a break. We'll come back for databases and CRUD. We're doing more Mongo. I'm showing you guys how to do aggregates and lookups and all kinds of stuff that maybe you know how to do in SQL and you have no idea what the proper replacement is in MongoDB. And then at 8 p.m., it's going to be a lot of fun. We're going to be building an RPG game using JavaScript. I don't think I'm going to use React, but I think I will figure out a way to wrap the imperative context of Canvas so that we can interact with it in a functional manner. So that'll be fun. See you at 8 then, and I'll see you in about, 15 minutes or so, 25 minutes for the next class, which is designing UX using Tailwind CSS. Thank you so much.